Dear students, I'm going to discuss with you the moment generating function of the multinomial distribution. First of all, let us recall the multinomial distribution. If a random experiment is repeated n times and each repetition is independent of each other, and on each repetition, the experiment results in one out of k mutually exclusive and exhaustive outcomes, say C1, C2, so on up to Ck, then the probability mass function of the multinomial distribution is given by f of x1, x2, so on up to xk is equal to n factorial over x1 factorial into x2 factorial, so on into xk factorial, and this whole thing multiplied by p1 raised to x1 into p2 raised to x2, so on into pk raised to xk, where the sum of the xi's, I going from 1 to k, is equal to n, and the rest of it you can look up and you have already studied it. So now let us focus on the MGF of the multinomial distribution. For this, students, I would like to first talk to you about the definition of the MGF of a multivariate distribution in general terms. ये जो मल्टीनॉमियल है ये एक मल्टीवेरिएट डिस्ट्रीब्यूशन है. अगर आपके पास k कैटेगरीज हैं तो आपके पास x1, x2, सो ऑन अप टू xk होता है. तो वो जो kth होता है दैट डिपेंड्स ऑन द प्रीवियस k माइनस वन वंस, और वो जो हैं दे आर k माइनस वन रैंडम वेरिएबल्स. So multinomial distribution is also a multivariate distribution. Therefore, as I said, I will first discuss with you expression of the MGF of a multivariate distribution, generally speaking. So what is that expression? Well, we can say it like this, that if the random vector capital X given by the components or the variables x1, x2, so on up to xk, if we have such a random vector, then if the expression expected value of e raised to t1 x1 plus t2 x2 plus so on up to tk xk, if this particular expression exists, if it exists for modulus of t1 being less than h1, modulus of t2 being less than h2, and so on, modulus of tk being less than hk, where h1, h2, so on up to hk are positive quantities, then, my dear students, this expected value, this very same expected value, is called the moment generating function of that random vector. So we can denote it by capital M, and then we have a bracket, and in the bracket we write T1, T2, so on up to Tk, and also we have a subscript immediately after M where we are writing x1, x2, so on up to xk. अच्छा, ये सारा कुछ जो है ये इतना परेशान कुन नहीं है जितना आप समझ रहे हैं कि कॉम्प्लिकेटेड है. देखिए, अगर आप k को 1 कर दें, देन यू आर डीलिंग विद अ रैंडम वेरिएबल. तो इसी के अंदर अभी फौरन आप k को 1 कर दें तो व्हाट यू गेट एक्सपेक्टेड वैल्यू ऑफ e रेज टू t1 x1, यानी वो 1 के आगे तो जाना ही नहीं आपको. तो आपका जो पहले आपने पढ़ा था फॉर अ रैंडम वेरिएबल MGF का एक्सप्रेशन क्या था? Was it not expected value of e raised to tx? तो अब सिर्फ इतनी सी बात है कि t की जगह t1 कह दिया और x की जगह x1. अब वो एक ही है तो आप वो 1 भी ना कहें, and it is exactly the same as what you had before, the expected value of e raised to tx. तो इस मेरी इस explanation से, I hope it is clear to you that even if we do not do any lengthy derivation, you can see that what I have presented to you is a generalization of that which you have in the case of one lone random variable. Now that you've got this basic idea, my dear students, now I can give you the expression of the MGF of the multinomial distribution. I'm not going to derive it for you, but I would just like you to have the expression. So it is, as you can now see on the screen, mx t1, t2, so on up to tk. Here x is the random vector, not the components, but the vector itself. So mx t1, t2, so on up to tk is equal to, according to the definition which I just gave, expected value of e raised to summation ti xi, where I goes from 1 to k. And for the multinomial distribution, this thing is equal to summation pi into e raised to ti, and the summation is for I going from 1 to k, and this entire expression raised to n. All right, summation pi e raised to ti whole raised to n. Students, I would also like to present to you the expression of the cumulant generating function at this point. क्योंकि आप जानते हैं ना कि there is another thing that is called the cumulant generating function, और उसका एक direct relationship है with the moment generating function. So in this particular case, the CGF, the cumulant generating function of the multinomial distribution, is given by capital K x t1, t2, so on up to tk, and x here is the random vector. So this entity is equal to the logarithm of mx t1, t2, so on up to tk. क्योंकि आप जानते हैं कि MGF और CGF में इसी किस्म का रिलेशनशिप होता है. So this is equal to the logarithm of summation pi e raised to ti whole raised to n, और जाहिर है कि चूँकि log लिया है तो वो जो n पावर में है that will come down and we will get n log of summation pi into e raised to ti. Coming back to the MGF, which I have presented just now, let us now consider how to utilize this MGF. तो आप recall करेंगे कि generally हम क्या करते हैं? We take the first derivative. अगर एक variable हो तो हम क्या करते हैं? We take the first derivative and then we put t equal to 0. और उससे what do we achieve? We get the mean. Then we take the second derivative and we get the second moment about 0 and so on. अगर एक से ज़्यादा variables हों, the story is quite similar. And here, if I now suppose that k is equal to 3, just to make it simple, what are the expressions that we will have? If we are dealing with a multinomial distribution having k equal to 3, in other words, we are dealing with a trinomial distribution, then, my dear students, the means of the random variables x1, x2, and x3 will be given by the following three expressions. Expected value of x1 is equal to curl by curl t1 of m t1, t2, t3, and then we have to put t1 equal to 0, t2 equal to 0, and t3 also equal to 0. तो इसको शॉर्ट करके इस तरह भी लिखा जा सकता है, curl by curl t1 of m, and then inside the parenthesis we can write 0, 0, 0. इसी तरह similar expressions for expected value of x2 and expected value of x3. अब इसमें I would like to show you that this is correct by considering n is equal to 2. इसलिए कि अगर n को मैं ज़्यादा रखूं तो then it will be a rather lengthy and complicated derivation. But if n is equal to 2, if our trinomial experiment is being repeated only 2 times, then what do we have? The MGF, as I just shared with you, is summation pi e raised to ti whole raised to n. इस वक्त n is equal to 2. So we can write this expression square. And now I would like to open it up. ये जो summation वाला है इसको open कर देते हैं. So what do we get? P1 e raised to t1 plus P2 e raised to t2 plus P3 e raised to t3 whole raised to 2. अब ये जो है expression इसको आप खोल लें. And you know the well-known formula, a plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2ac plus 2bc. तो वही यहाँ पे apply कर लें and you get the expression that you now have on the screen. अब इसके बाद if you would take the partial derivative with respect to t1, यानी हम अभी पहले t1 के हिसाब से करेंगे, उसके बाद t2 के हिसाब से कर सकते हैं और t3 के हिसाब से. तो t1 के हिसाब से अगर हम करें तो what do we get? We get simple expression. It seems to be long and complicated. लेकिन जब आप term by term उसको करेंगे तो exactly what you have on the screen, you can see that. That's what you're going to get. और उसके बाद when you put t1 equal to 0 and t2 also equal to 0 and t3 as well, then it becomes really simplified and it becomes 2p1 square plus 2p1p2 plus 2p1p3. As simple as that. कुछ terms 0 हो जाती हैं, so they can be rubbed, और 3 terms जो बचती हैं they are these ones. अब इसमें से भी जाहिर है इन terms में सब में 2p1 exist कर रहा है, so 2p1 can be taken out common and we have 2p1 into p1 plus p2 plus p3. But students, for a trinomial experiment, don't you know that p1 plus p2 plus p3 will be equal to 1 because sum of the probabilities is always 1. So uski jagah we just write 1 and then what do we have? 2p1 into 1 yani 2p1. Bilkul isi tarah I have presented on the screen the derivation of the second one. That comes out to be 2p2, and for the third one, when we are taking the partial derivative with respect to t3, the final answer comes out to be 2p3. तो मैंने आपसे कहा था ना कि जब 0 पुट कर चुकते हैं डेरिवेटिव लेने के बाद, तो that gives you the mean. So पहले केस में that is the expected value of x1, 2p1. Second one, expected value of x2, 2p2. And third one, expected value of x3, 2p3. तो क्या ये जो result आए हैं, are they actually correct? Students, do you not know already that for the multinomial distribution, expected value of xi is equal to npi? और यहाँ पे n is equal to 2. So will it not be 2pi? And that's exactly what we've got. ये हमने जब MGF के तरीके से निकाला तब भी we got exactly the same result. 2p1, 2p2 and 2p3. Generally speaking, for the ith x, the expected value is 2pi.